Hello, everyone. I'll try to avoid putting it in the full screen mode, and I hope you see it like this because I have to switch between windows, and it's more convenient for me to keep it like this. So if you agree, I'll keep the presentation like this. So our two presentations are in a way connected, but my presentation will provide a brief overview of the landscape and the context actually for skill development, for upskilling as we call it today. And I will talk a bit about the European Open Science Cloud as the main concept and the main actually feature of that context that you should be working in. And Obrad will then focus on specific skills related to research data management. So this is a brief overview of today's presentation. We will talk a bit about the European Open Science Cloud, just to present what it is. Then we'll mention the open science skills for researchers, a general overview and the importance of these skills. And then we will focus on the EOSC related skills because these are the same. They include open science skills, but they have a very defined focus. We will mention relations to transferable skills because your project, SOCA-U, is very much dedicated, and the institutions in this project are very much dedicated to transferable skills. And then I will show some examples of the materials that are available for you, the things that you can start doing now independently of that, whether your institution is running any programs dedicated to EOSC and open science or not. So there are resources that you can use if you want to upskill yourself. So let us take a Menti for a moment. I'll ask just one question now and one later. So let's go to Menti. You will probably be able to find the link in the chat. Yes, I can go back if you want to scan the QR code, and we can go here later. Okay, if you want to scan the QR code. So please respond to this one question. I don't see any responses. Oh, they are coming.
You can find the link in the chat with a code number.
So this is interesting, and this is not unexpected because the concept is quite difficult to explain. The European Open Science Cloud, so-called EOSC, has been around for some time. It was first mentioned around 2015, but it was since 2017 that it became a very important part of European policies and discussions. And it's interesting to me. I was involved in an EOSC related project, a regional project here in Southeastern Europe, and we ran a survey, a landscaping survey, and the results were quite similar. So many people didn't have an idea what it was. Some of them heard but didn't quite understand, and some people were informed that those were mostly people who were involved with some infrastructures, research infrastructures, and who had already participated in some European projects. So it's quite expected for me, and I will now try to explain what it is and actually to provide some links where you can take, where you can find more information. So one of the problems why people don't know much about the European Open Science Cloud is that the concept is very complicated. And in my opinion, and I'm someone who's been involved in promoting EOSC for at least 5 years, this is one of the most important reasons. It's too complicated, it's too complex, and it's in a way sometimes it's too technical, and people don't really understand what it is. So basically, EOSC, this is an initiative by the European Commission, And the aim of this initiative is to develop an environment, and this is a crucial term, it's environment, it's not only a project, it's not an infrastructure merely, it's an environment that includes policies, that includes stakeholders, that includes skills, that includes digital infrastructure, and a system of rewards and incentives to facilitate this, and funding, etc. So this environment that includes all these things is intended for researchers primarily, and then for companies, for citizens, etc. And this environment should make it possible for them to publish, but also to find and reuse data, because Obred will talk more about this. Data are not sufficiently used because data are not available in some research products. They don't make projects and don't make their data available. So people repeat research, repeat experiments to find this data. Also, some data are available, but it's difficult to find them because they are not on interoperable infrastructures. They're on some scattered on some websites. Fragmentation is huge because each project, each institution, each country, they develop their own infrastructures that are unrelated. They don't follow the same standards. And the idea of EOSC is to connect all these things and to make a better use of the available infrastructures, to define standards, to enable this collaboration among researchers, but also among researchers and the industry, to involve citizens, to make data available to citizens. So this is very ambitious and this is very complex. And if you're to explain EOSC in one sentence, it is very, very difficult. But the crucial concept is digital. This is everything digital, infrastructure before all things, digital skills, and then it's an environment that is very complex. So I copied this sentence from some policy documents. So the idea is to develop web of fair data and services. Services are also another concept, and I will show in a second what it actually means. So the interface where you can see what EOSC aims at and what EOSC offers, because EOSC now offers something, is this EOSC portal. So this is a web portal where you can find information about EOSC, and this is one page about. This is not a home page, so this is a home page, and you can find various resources there. You can find news, you can find policy documents, links to policy documents, information about policy landscape in various countries, etc. So this information is brought together here. But the most important part of this portal is the so-called EOSC marketplace. So this is the most recent design. The design has been changing over the past year because it is being developed within several projects, but one of them is main, and I will talk about it later. So this is a searchable database where you can find various resources. You can find software tools, you can find services, you can find publications. This is still in progress, not all publications. For example, if your repository is harvested by the open air, then your publications will eventually appear here. Now it's a very limited number. It's about 2 million publications, but there will be more. But one of the most complete facets of this EOSC marketplace are the services. And you can find various services here, computational services, data storage services, even some training platforms, various services that have been developed within projects funded by the European Commission, and also especially those developed by various research infrastructures in Europe. And many of these are open access. You can see that the majority of services are open access, which means that you can use them. In most cases, you can go to the service website and then use it. So you have a page with a description and you can access the service here, go to the service. Sometimes it's open access conditionally, so you can send a request and use it, but eventually it will be available to you. So this is about these services. The services that are not open access, there is a possibility to order them, and there is a possibility to order them using this EOSC portal. So this is for me the most easiest way to explain the EOSC. The EOSC is to direct people to this EOSC portal and the EOSC marketplace, and say, so if you don't understand the concept, if you don't understand the aims, this is the results. The result. This is something tangible, and you can go there and you can see how it works in practice. There will be more. It is going to be developed more. For example, the search functionality is not perfect. It doesn't support advanced search, but it's being developed. So this is something that is already useful to you, and you may not be aware of it, but you can go here and use. And you can also, there are ways to contribute. If you're part of a project, your project can contribute to this. There is this providers hub. So if your institution or a project develops some services, you can register your services here. We call this process onboarding, and make these services available to the others, either as open access services or as services that are conditionally available. This may involve payment or some negotiations, etc. But these services have to meet some technical requirements, and this is quite demanding, but the information is provided and support. So this is for me the easiest way, and you will when you ask questions, I will see whether this is sufficiently clear. But this is, go to this website and you will see the tangible results of the EOSC, and it's easier to understand its benefits. So this is the EOSC portal. I already showed this. So you can see this is on the home page, the screenshot of the home page. So in order to make it easier for you, you can browse by scientific discipline, or you can browse by research activity, and then you will get a subset of these specific tools, of specific research outputs. And also here is a link to, I will talk more about this platform. Here is a link to a course. So you can take a course and learn more about how to use the EOSC portal. As for open science skills, this is something I will mention some documents, because this is an area that is subject to huge discussions, and this is an area that is included not only in European policies but also in national policies. And here these sentences are an excerpt from the document that is cited here. And this is one of the key documents because it's a high-level European document, and this document reflects the awareness of the European Commission of the importance of open science skills. And this document was defined in 2017. So I'm citing it because I want to highlight this shift of focus since the development of EOSC. So in 2017, EOSC became something important, but something that was mentioned in discussions, and there were not tangible results of EOSC. And the open science skills were defined in a kind of an ordinary, let's say, framework. They were mostly discussed in the context of open access publishing, data, research data management, data production, etc., data reuse, or licenses that enable data reuse, the FAIR principles. Then also the multidisciplinary aspects were also highlighted, and the skills and expertise were already a very important topic. Citizen science became an important topic, so it became a kind of a buzzword. There were more projects involving citizens, because citizen science actually improves and raises the awareness of taxpayers of science, but it also actually improves the usability of research outputs. So that was the framework in which open science skills were discussed. And that was the period when some recommendations were formulated, and when a discussion about revising some frameworks, training frameworks, educational frameworks, curricula, PhD study programs, qualification matrices became job descriptions. That's the time when these topics became current. They were included in these recommendations, but the process, well, this process is still not finished. It's a slow process, and there are many challenges to this process. An important thing that we will keep on mentioning until the end of these presentations are incentives and rewards, because in the old system with different type of incentives, rewards, this old system is not compatible with open science principles, and it sometimes conflicts and discourages the adoption of these principles. So this is from the same document. And what is probably the most important for the universities, and actually this is an area where the greatest progress was made, is integration of open science in PhD education. So one of the first signs that this adoption has started was the introduction of data management plan courses, research data management courses as a part of PhD studies, and these courses were mandatory, and support was provided by librarians, by teachers, because this was a new topic for the support staff and for teachers as well at that time. Another sign that the adoption started was the introduction of mandatory DMPs for PhD thesis. So some universities introduced it. In Serbia, the University of Novi Sad introduced it. In Europe, this is already a very common point, etc. But another thing that we will mention later are transferable skills. So transferable skills and training on transferable skills became very important. This largely coincides with the rise of fake news, of the observation that people who complete studies are usually not able to immediately jump into industry to take the responsibilities, that, for example, they lack some so-called transferable skills. These are skills that are not related to any specific disciplines. These are skills that are widely applicable even in everyday life. So, for example, these are some of these skills include critical thinking, writing abilities, communication skills, etc. So they observed that these skills were lacking from the training programs, and that people lack these skills, and that this was an obstacle when they started to evolve in industry and to try find jobs, etc. So this is about this concept that is related to open science. And then EOSC appears, and we now start speaking about EOSC related skills without ever explaining this difference, if there is a difference between EOSC and open science skills. So open science skills, they are EOSC related skills. So EOSC related skills include open science skills, because EOSC is about enabling open science. But now we have an important moment here with EOSC, and this is the infrastructure, digital infrastructure, that is very complex. So in order to use this complicated infrastructure, you need some skills to communicate with this. You need some digital skills. So these previous open science skills since 2017 and before, they are in a way abstract. So, okay, you can use, you should make your data available, etc. But now you have an infrastructure in this infrastructure, it includes a catalog, and there are some services, and in order to communicate with these services, you actually need more than theoretical knowledge. You have very specific skills that are digital skills, that some technical knowledge. You have to understand how this infrastructure works. So it's a bit, these are open science skills, but a bit more complicated and a bit more with a specific technical flavor. And one of the challenges, because EOSC is very complicated, one of the challenges is sustainability. So if people don't understand it, if people don't know how to use it, if it's complicated to use it, then it won't be used, and it won't be sustainable, because people won't see the use, and institutions and countries will stop funding it. So it will fail. So that's important. So you have this is a bit paradoxical situation. So you have an infrastructure, but in order to use this infrastructure that is meant for you, that is meant to support your research, that is meant to support your open science activities, you need additional skills. So there are the other documents, and this is a document that decided here from 2021. This is one of the crucial documents, and there was a training working group. It changed its name as far as I remember, but there is always some task force that is dedicated to developing skills and to explaining, identifying which skills are needed, and to creating training programs for these skills. So this is the definition of it, and this is the result, a visual result, a tangible result of this document that is cited on the previous slide. So it might be difficult to understand, but I'll try to skip the tricky part. So EOSC has some kind of infrastructure. And I won't be explaining this. You can find it on the links that are provided. It has some core services that are related to this portal, to this catalog and marketplace. So this catalog and marketplace, they communicate with some external services such as your repository, institutional repository, your services, computing services, etc. Some disciplinary services, infrastructures, etc. So there is a kind of infrastructure. It's a concept how it works. So in order to make the best use of EOSC, which has this kind of infrastructure, specific profiles are needed, and they define in this document, they don't define job positions, they don't define, they describe in detail specific, I don't know, fragmented, granulary jobs, but they define those roles, the main roles, and these roles cover this whole circle related to this EOSC infrastructure. So you can see, for example, this is color coded, and for example, I'm a librarian, so library information science, this is this kind of purple, and these roles include some library-related skills, but they also include some computational skills, some digital skills, ICT skills, IT skills. So this is, wherever you see green, this is something, for example, this profile needs training in IT skills, but this profile, EOSC educator and trainer, they need both. And also data stewards and librarians, they need to have librarian skills, but they also need discipline-specific skills in order to effectively perform their duties. So it's about it. This is a theoretical framework, and now the tricky part is implementing this framework into job descriptions, adjusting introducing new jobs. But the trickiest part is actually redesigning the curricula to support this, to provide all these, to create people who can perform these roles. And this is quite difficult. So this is an example how it looks, a description a high-level description of a role of a researcher. I picked just those that are related to you, or an EOSC enabler who is, yes, a researcher, but also needs to have some IT skills and has to understand the legal aspects of EOSC, rules of participation, etc., licensing for software publications, etc. So the policy, the challenges are many. So first, you need to have policies. So you can have the infrastructure, but if your institution, your country don't have policies to support this, people won't be using this because they don't have to do, because nobody has told them, because nobody pushes them. One of the main challenges is the integration of skills into curricula. This discussion has been opened long ago, but one of the question is, okay, we started including this in PhD studies, but when it's not too early, PhD studies, it might be too late. So perhaps we should go earlier to master studies, or even earlier to bachelor studies, or even start with very young people, mentioning some things already in secondary school. We haven't, well, PhD studies are still a sufficiently big challenge. Also, incentives and rewards. This is a huge challenge, because if you don't have incentives and rewards, and you still have research evaluation systems that focus on impact factors and prestige, well, this doesn't encourage open science practices. Also, another challenge is that somebody has to take care of this, of the training, and current staff usually they lack expertise, they need training themselves. And then if they get some informal training, this should be certified in order to involve them in some formal process, training process or education process. So this is also a challenge. So it takes a process to achieve this, and time. And also senior researchers, who are often decision makers, they are insufficiently interested. They don't understand this. They don't have the time to deal with this. And that's they sometimes even discourage young people, and actually they are those who should make these decisions whether to integrate this in the curricula or not. Another thing that I mentioned that is very important, I won't go into detail, but transferable skills are mentioned in all these documents dealing with open science skills and dealing with EOS. They are explicitly mentioned, and they are very, very important. So, for example, in order to practice citizen science, you have to have an idea of what global citizenship means. In order to practice anything, you need critical thinking. Information literacy is very important, because you have huge resources of information and you have to process this information. Digital skills are also very important. So it's, I believe it's self-explaining why these transferable skills are so important. They've always been important, but they are increasingly often mentioned in policy documents and in training programs, because it was with the development of digital infrastructures that people became aware that we can have digital infrastructures, but in order to use them, people need to know how to use it. And also, digital infrastructures don't save the problems of some old problems. For example, fake news. This is a huge problem, and the fake news problem was one of the triggers to start talking more about transferable skills. So it's very important, and in order to be employable, you sometimes need transferable skills more than some specific knowledge, because there are some things that you can learn while working, but those skills are essential. You can't learn them easily. This is something that you're gaining throughout your life. And I'm mentioning this specifically because this Circle U Alliance, 5 institutions developed. This is a very interesting document here, and I recommend reading it. They developed a kind of a pilot program related to including transferable skills into curricula and university training. So what can you do now? you don't have, let's say you don't have a course at a university that deals with open science, you don't have research support staff who can train you about the EOSC. So resources are available. One of the main projects that is currently being implemented is EOSC Future. It ends in September, but it will leave behind resources, abundant resources. And one of them will be Knowledge Hub. It is about to appear any day. So it actually will offer a kind of a catalog of trainings integrated with a training platform, and I can show this catalog of learning resources. I won't show this because it's the same. The interface is the same. It's just one click away from what I've already showed on the catalog and marketplace. But this is the training platform, the learning platform. You can log in, it's free. You can log in using either your institutional login or your Facebook, your ORCID or your Gmail account. So you can use social login to access it, and you have some courses here. So you have to log in, and then you can just pick up a course. And this foster course, it's very important to learn about open science. This is one of the best courses and most comprehensive about open science. Is completely free, so you can register here and just train yourself. And also, it's very important, you have use cases on the EOSC portal. You can visit this link. These are discipline-specific use cases where people explain how they created services and onboarded them to the EOSC marketplace, and how they used the already available resources for their research. So these use cases are sometimes the easiest way to explain how it actually works in practice. So these, I've already shown this, so this is where you can find. There are currently 96 resources, but there will be more, because the process of these are resources created in other projects. So this is a catalog, and you can search and find resources that are available on other platforms where you can take training courses. I've explained this already. You also have other resources, because there have been many projects related to the EOSC, and I'm sharing some links. And I would like to draw your attention to a project that started last in September. It's Skills for EOSC. I'm not sure whether it has a website, but keep an eye on this project because it will offer many resources. And one of the main ideas of this project is to create certified certification schemes and to some certified courses. So the takeaways are that you should be informed about international initiatives. Keep an eye on them, because your university may not be aware of them. You may not find the information about these on the resources provided by a university, but you can do this independently. EOSC is important for you, so start using it. Even if you don't understand the concept fully, start using the EOSC portal, start using the marketplace, start using services. So you don't even need to understand it. When you have something tangible, just use it. If you are a decision maker, and you're probably not, but you can draw the attention of your decision makers to this. Embedding EOSC related skills in curricula and training programs should be a priority. We should start doing this as soon as possible. Rewards and recognitions are very important. There are currently several projects at the European level that are trying to develop a framework for these rewards and recognitions, and to push the official evaluation system away from the impact factors. So I expect some results in future, in the following years. And also, you can start upskilling yourself now, this very moment, because resources are available. These courses are not difficult to use. They're usually easy to understand, and just start today.
My name is Obrad Vučkovac. I come from University of Belgrade. I'm a librarian at Vinča Institute of Nuclear Sciences, and I will here try to explain a little bit more on some basics of research data management but I will more focus here on some practical insights that you might you can be aware of when you do your data management practices. So, so what is RDM, or research data management? You probably by now, if you are dealing already with research, you probably figured out that most of the funders and institutions are now very keen on open science activities, and that science should be made so everybody can freely and easily access it and use it. But mostly open science is usually perceived as just open access, but it is not just that. And more and more in later days, founders and other institutions and publishers are trying to focus their funds and to persuade researchers to do to publish their data, and because of that to watch for the data to be able to be later reused in a more meaningful manner. So like in probably if you've seen in Horizon Europe agreements, this is just one example here. In Article 17, there is this communication and dissemination, open science and visibility things. And one of the issues here is open science and research data management. And I will now explain you more about what the research data management is, and other terms that you might find here, like FAIR principles and also data management. But I will focus more about it later. Research data management refers to organization, storage, preservation, and sharing of data that you done through or collected to your research during your research project. It is a way to do a good practice, and the main focus and why you should do your RDM activities should be to safely secure your data during your research and to preserve it for reuse later after research. And it should also be, the data should be also be findable, and it should be understandable for others to use, and including yourself, or your future self, for I don't know, 10 years from now, you will probably don't remember what you did, how you did your research, and it should be this is what RDM should appoint and help you with. And like I said, why do we need it? We need okay, RDM is probably perceived by many of researchers as some extra activity, some extra laborious work that needs to be, and it is. It needs extra resources, probably extra partners to work with you, but it is a good way. It is way of good research practice, and it will be beneficial to you in a long way. And it can improve your visibility, can increase your citations. Your scientific communication cooperation will be better, because the science behind you, the science will be more transparent, and it will be more prone to reproducibility. And also data will be safer because it prevents a loss of data during and after the research, and also it can have financial benefits as well as ethical benefits, because you can reduce the duplication of efforts, because probably somebody else has done research similar to yours, and you can reuse that research as well, or somebody else can reuse your research too, especially if this is true, if these experiments are expensive, or if these experiments are some kind of when you are observing something in nature that happens now and probably never, like astrological observations. And also, one of the most important things to consider is the requirements by your institution, your funders of your research, and more lately by the publishers. And research data and metadata needs not to be ready just for use by yourself or your colleagues and partners, anyway, by humans, but also to be ready to be machine readable, and to be used by computers as well as humans. So when should we consider these research data management activities? Well, it should be done throughout the whole research process. And this is just a simple schema of research data lifecycle, which starts, it can start with the initial planning phase, when you and your partners plan how to do research, what data would you need, and then proceed to this active phase of research with collecting, gathering, or generating new data. And that data should be then analyzed and processed, and after that you go to this more phase which is more concerned to preserving your data and sharing and publishing that data. That's all in order to be reused later on and to begin a new cycle again. This cycle doesn't have to be like this cyclical. It can also correlate with different stages and go back and forth as well as it needs. So to start with the planning phase, now more and more funders are asking researchers to make something called data management plan, or sometimes it can be called in different names, but data management plan, or short DMP, is the most common name. It can also be called, I think, Outlook management plan, or something like that in different settings, but DMP is most common way. I will refer it in this presentation like that. So we have here example of some Horizon Europe grant. This is just an example of agreement, and you can see this sentence that is bolded as to that beneficiaries must establish a data management plan early on at the beginning of research. And I think this is probably the first result of the output of the research project that is that needs to be done. It depends of the funders. Some funders ask DMP during the registration phase and participation phase, and some like Horizon asked it after the project has started. Good thing about DMP is that you can regularly update it. So it doesn't mean that you can answer all the questions regarding your data immediately at the beginning of research. Things can change. You can find new data or some other research activities that requires data, and you can change this DMP, but it had to have some kind of version numbers, and you have to regularly report that to your funders. So how does it look? DMPs are often results in like a plain text format, just a kind of document which states what are you going to do, what data are you going to collect, how are you going to collect it, who will be responsible for what, and are you going to use some pre-existing data? On which formats will you save it, and what repositories you will choose, and what licenses you will apply for that data to be usable. So, and usually funders and institutions provide templates for writing DMP, just a series of questions that you should answer, and usually they sometimes yes, sometimes no. They can provide you with some examples or explanations on how to write that and answer to that questions. And also there are tools developed just for writing DMPs. They're very convenient tools. I just numbered here just 4 of them. There are much more, but these are the most usual one, and some of the funders recommend of these tools, like DMP Online, which is a great tool, DMP tool Argos, and I will exhibit just in a moment how it works, and the Data Stewardship Wizard. They all work have similar agenda to a similar goal to make a DMP, but some work on some other principles and some others. But I will now show you how Argos work. Argos was designed as a tool with OpenAir, and you can find it on. Sorry, I didn't. Yes, this is the. I will leave it in a chat. This is a link to Argos, and yeah, you can log in with Google account, Orchid, OpenAir account, which we have a lot of usability on UDAT. Yes, you can use it as well, and yes, it's free to use. And how it works? It starts when you want to build your DMP, and you should assign, when you, this is just some examples of DMP. They're not full, just to show you. And how it looks, you create, okay, I will create another one. You start a wizard, or you can import it from another file. And you should put here a title of your DMP, just a short descriptions, who will be involved in creating this DMP. And also this is connected with Orchid, so it can be like this. You can find some names and from the list, and also if you are not in that list or you're not from Orchid, you can insert it manually. To select your organization, also it is connected to other services, and language, and who will be contacted, funding the organization, grants, what your project is, and what license this DMP will be accessible later on, and access rights, and also, yeah, the DMPs are in Argos are consists of various data sets that you're going to describe everything, how you're going to collect them, and each data set you describe in your own way. So just how it looks. Just one example. I here have just examples of data sets. I will just add additional one. Yeah. Okay, I will fill it manually. Just some title. You have fields with asterisks are fields that must be used. And let's see. Okay, there is a Horizon Europe template as well, but I didn't set it here. But you should acknowledge your or choose a template which are you going to use for describing this data set. And if you go to next, okay, so you can you can see now how it looks. It has some predefined fields, like main fields for data usage, and all those fields have so those sections have questions, and like what is the purpose of data collection, generation, or our generation, its relation to objectives of the project. And also you have here just an explanation what is expected of you to answer in this question, and also additional resources if you need some references to something, to read some additional text on this. Also answers can be like this, they can be checked. Answers can be checked from the predefined answers, and also you have a field where you can add additional text, which is a free text, and to write something to further explain what you meant by this answer. But this is just optional. Like I said, all with asterisks are the question that needs to be answered. Also, you can skip to other questions like this, and because this document is very long, elaborative one, and also you have questions where you can just check. If you check, sometimes yes, it's optional. If you check yes, additional questions arise, or if you say no, maybe that questions will not arise. But it is always advisable to explain. If you chose no, explain why you don't want to do this or to do that. Explain it, because the purpose of this document is not just for the founder's sake, it is also, and the main purpose is for yourself and for researchers who are involved in your project as well. So if you, let's say, if you have a partner in your project that came in some not from the beginning, and probably that partner would like to know what to do and how to do everything with the data. So you just provide him a data management plan, and everything is written there, how you're going to deal with the data and what his or her responsibilities should be. So, and so you should quickly, you should check and fill this whole document. On every question, like I said, you try to provide as much as more elaborative answer if you can. So when you're finished, you have just to save and to finalize this. I will not do this here, but you should finalize and finalize your document, and it will be saved for later on. I'll just show you here just a few examples of public DMPs or DMPs that are already finalized. and you can see how it looks. So if you finalize it here in Argos, it can be provided with DOI from Zenodo. This is one of good things to have, for it has a persistent identifier. And also it can be exported, well, like I said, in PDF or Word document. I will try to, okay, this is a PDF example of this DMP. This is a PDF at the end. So you have some basic description of data set, and also data set description, like I said, questions with the answers. Sometimes these answers are just plain text. Sometimes you just pick choices from the this bullet points. You can select points, and yes, this is a way how this PDF looks like. And also you can export it in XML or RDA JSON format, and looks like this. I hope you can see this. This is a JSON format, but it is looked from the browser. I'll just, yeah, yeah. This looks just from the browser, but also it can be on in XML as well. So why is this important? Why is this important to have JSON or XML document format? Because now more and more founders are looking for DMPs to be understood, like I said, like understood not just by humans, but also by machines, and it can be later on reusable with the computer power, and to use it with the founders, and to automate some processes later on, like with this data set, you can automatically maybe reserve some space in some cloud service, or in a repository, or it can also give a response to a funders, which licenses did you choose? Did you choose a license that is mandatory by the founder or not, and so on. Yeah, that's it for planning phase. During the active phase, when you are collecting or gathering data, generating new data, things to consider is how to organize your data. Please discuss with your partners and describe it in DMP, how you're going to or the naming conventions, and how you're going to name your files and your folders. Agree on terminology, whether you use abbreviations or not, or some or the schedule of the words in the file name. Also, if you have more words in file name, separating best with the underscore, or maybe just yeah, the best with the underscore. Don't separate words with blank or comma, because that files can be used for automatic analysis, and it can be it can broke the code because of the wrong file naming. Also, if you are using something like date formats, agree on the date format you will use, like when, in what format like this you are going to use. Also, watch out for folder structure. It can be use it probably the best in some hierarchical level, with the probably the main folder is the folder of your project, and after the experiments should be in separate folders, and so on. Also, name your folders by your project, experiments, whatever, just don't name it on your colleagues' names, especially not on your colleagues' nicknames, because partners go and come and go from the project, and you can probably don't remember which is which folder, and then somebody else who joins the project lately could have difficulties to understand the whole folder structure. Also have some kind of README file for explaining this folder structure. Also beware for version controls in your when you're naming your files. If you are describing which version it is, keep it simple. Version 1, version 2, _1 or something like that. If you make final version, make it final. Don't make it final version 2, final version 3, or and so on. So it will just be confusing. Final version is final version. During your active phase, especially be aware of your writing down your metadata for your data sets. It is very important thing to do. Try to capture everything, and even some things that you might consider that is not important. It can be important for somebody else, but maybe if not, it's not important for you. So try to figure out early on which metadata you will be using. That metadata should be something that is already in use. It's the best thing to use. So use something that is already in use in your research community. If there is no such thing, maybe you can invent your, but keep in mind that you will need to provide a schema to use and all the other documentation on everybody else to use that metadata. Metadata is like it's a data about data. It's a data about describing other data. There are a lot of courses. I'll just here put some resource under these resources, just some courses on where you can find more about this topic, because it is very wide, a very broad topic to discuss now, but this is one of the most important things you can do for your during your research data management process. Also, yes, ask your librarian for help. Most of the librarians are familiar with this, and they can provide you with some additional information and help to use this. There are some tools like Dublin Core Generator and a checklist. There are much more. You can go to Fair Sharing or RDM Metadata Directory to find more about it. Also, keep in mind that metadata cannot explain everything that you need about your data. You should always keep in mind your documentation, everything that you used to generate and during the active phase of your data, and it can provide additional information on your data. It can be data dictionaries, code books, software codes, calibration of instrument and instrument documentation, and so on. Can use electronic lab notebooks for this, like Jupyter Notebook, or just simple README file is very good to keep everything, everybody informed of how you what you did with your data. Also, GitHub, GitLab, always good sources to help. If you are dealing with sensitive data, I suggest you to use Amnesia, which is also developed with OpenAir. It's a useful tool to anonymize your sensitive data. Also, to clean your data, to keep everything tied up, you can use OpenRefine. Yeah, data protection phase. Just be aware of always protect your data. Don't have just one copy. And okay, but first of all, especially if you're dealing with sensitive data, you should keep mind of who will access the data, and that is something that you are obliged by the law as well. And keep in mind who will access your data, protect it with passwords, with firewalls. I'll always update your antivirus software. Or you can also encrypt your data with some tools. You can be used, but just simple passwords. You can use 7Z for that, and Microsoft Office tools also have that possibilities. Also, you can encrypt your whole hard drive with BitLocker or Verakit as an open source solution. Yes, and to manage all those billions of passwords, you can use 1Password or LastPass, and there are many more other tools for that, but this one I recommend. As far as protecting the data, you should be aware of always backing up your data. And if more partners are involved in a project, you should discuss this during the planning phase, during the writing of DMP, how backup is going to be organized, and who will be responsible for that. Is it going to be everybody or just a few people? And maybe it's one of there are many rules how you can do it, but one of the most common is the 3-2-1 rule, which states that you should have always three copies of your your data that you're actively working on, 3 copies on 2 different media, with one offsite, not on your 2 different media, like your computer or your USB stick or some hard drive, but one should be offsite, probably best on some cloud storage. But beware, if you are using cloud storage, be aware of GDPR. Sometimes it shouldn't be on your some sensitive data on cloud storages that whose servers reside outside of European Economic Area. So something to read some documentation prior to choose your cloud storage. Just beware of this thing. Yes, and one thing to remember, backup is not the same as long-term preservation, which I'll discuss later. Backup should be done just during your active phase, because like Murphy law says, if something bad can happen, it will definitely happen. So it's better off to have some reserved, some extra work or safe in some other places. So when it comes to later on, when you finished your gathering of your data, generating your data, and want to preserve it for long time preservation, it is obliged, like I said, with funders and especially now with institutions. You should always check what you should be preserving, because storage space in data repositories, which you should share your data, is not always free, and sometimes you are limited with space. So you should probably keep in mind what data needs to be preserved. So some rule of the thumb should be that you preserve data that is not repeatable, like I said, or some data from nature that cannot be repeated experimentally again. Also data that are generated during some long or expensive expensive experiments. So keep that in mind, that you don't want that data to be lost after 2 years because of the financial situation. And yes, choose wisely your formats. And what formats should that data be? You want to be an open format, a sustainable formats. You want that data to be used even after longer periods of time. So you don't want to have some special version of software that was used for that data. So if, for example, if you have proprietary formats like that Origin has, I think it's ODJ, or I can't remember, Origin software, or Microsoft Excel software has this XLSX format, which can change because of the new software that they are applying. So, and if the format as a software change that reads that format, it can, some data can be lost. So in order to prevent that, you should keep your eyes on sustainable formats. Like CSV is always a good solution for that. And always keep in mind to deposit not just data, but also metadata. So data about that data, and also documentation that follows that data to further, to better understand it. How to choose your repository? It is best to deal with it and during the implementation, during the DMP phase, and agree with your co-workers, with your partners, what data repository should you use. It should be trusted, some repository that provides you with persistent identifiers, and also if the position in that repository costs money, you should be aware of that to relocate your funds. It's always good to have to put it in some repository that is used by other broad research community. But if that's not the case, you can use general repositories like Zenodo or Figshare, or you can always use your institutional data repository if your institution has one. One good site is to look is retreedata.org, which is a registry of data repositories. You can find all the information. It has a good filter for all these repositories. You can choose by your discipline, or whether it is free or not. And it is a good place to start. And like I said, agree with your co-workers on this project. Always, yes, associate your data with your publications. And for a license which your data will be published, and access controls, you should always look for your funder requirements, because some funders like European Commission ask for data to be ensured with open, should be deposited with open access, with CC BY or CC0 licenses. Metadata should be deposited with CC0 or other equivalent and licenses. That is for European Commission, but you should also look for other documentation about your funder. Yes, but this doesn't mean that data should always be open access. Some data, because of legal terms or patent rights or sensitive, yes, information, shouldn't be open. So, but you should be pointed out during your DMP writing, should point out that data, because of the so-and-so, cannot be openly available. And you have in this proposes this line as open as possible, as closed as necessary. So as a way of upgrading this research data management, some principles like that's called FAIR principles were developed. I'll just quickly go through this because we are running out of time. Yes, what are FAIR principles? Actually, you can find it in a research or in a funders requirements that they are asking for you to do your research to have a responsible management practice or with research data, and you should be in line with FAIR principles. That is something that most now of the funders are requiring, and this is just an example of RISE in Europe. And this means that FAIR principles mean that data should be described and organized so it can be easily findable, accessible, interoperable with other data and other resources, and ready to be reused again by others. And the first, this concept appeared in this article in Scientific Data, the FAIR Guiding Principle for Scientific Data Management and Stewardship. I suggest you to read it if you are not aware of FAIR principles to understand it, but I will just try to explain it here later on in further details. But like I said at the beginning, your data should not be ready just for humans. It should be ready and also for machines to be used. And there is also one new acronym reading of this FAIR principles. It can be also created as fully AI ready. It's in line with what is happening today. And yeah, so first principle is findability principle, and it is used not just, you should be aware that the FAIR principles are not used just by data. It should be used, but also with metadata, also with infrastructures and software and so on and so on. So it is not just for data, but for other research resources. So findable principle states that all data metadata should have assigned globally unique and persistent identifier like DOI, which is most of you are familiar with, and also it can be ARC handle, URI, many others, but it should be, accent is on this globally unique and persistent. And yeah, that data should be described with rich metadata. That is why I point that earlier on that metadata is very, very important, and it should be putting your attention more on metadata than on others. Yes, yes, one of the most important things is to choose a resource where this data and metadata should be deposited. Like I said, if you are choosing your data repository, you should be aware if it is registered or indexed in some searchable resource like this ray3data.org. Accessibility principle states that all the that users need to know how this data can be accessed. This doesn't mean that data should be openly available. FAIR principle doesn't mean that data are open data. It is not the same. This is just about how this data should be accessed if it's open or if it's closed, but somebody is asking you to provide you with the data. So it is not just the old way of just sending data through email or some other server. It should be on some repository that has standardized communication protocols that are open, free, and that can be implementable in all systems. Also, if this data is sensible, it should have some kinds of authentication, authorization procedure to protect the access to that data if the data needs to be closed. And also, one of the most important things is that the metadata needs to be accessible freely, openly accessible, even if the data is not accessible. So metadata should be always free to find and to see. Interoperative principle can be a little bit trickier because it relies mostly on some technical perspective, and you should have some technical knowledge. It states usually that all this, your data and metadata, should be integrated and connected with other data, with other metadata, so it can be used to have better and more automatic process and to analyze the data and process data in some seamless fashion with computers. So metadata should use, and data should use, a formal, accessible, shared, and broadly applicable language for knowledge representations like RDF schema, or web ontology language, which is OWL. And also to use vocabularies and ontologies that follow FAIR principles. So if it's connected, the data, if it's connected with some other resources, that resources should also follow FAIR principles, at least these basic ones, to have PID, or to persistent identifier, to be in some space which is accessible with standardized formats. And also the last principle is reusability. So data, metadata should be, and data should be richly described with accurate and relevant attributes, and it should be released with clear and accessible data usage license. So that means that a license is available not just for people to read, but also had this machine readable component. So if it's CC BY license, you should put in your metadata also and URI of that CC BY license, or link to that CC BY license. And also metadata should meet domain relevant community standard as well as data. So that means, like I said, if domain relative community standard for some data is some file format, you should use that file format for a long-term preservation. Then your format maybe that you are usually used to work with. So there are tools on how to assess how fair is your data. There are tools like this certified by DANCE self-assessment tool to improve fairness of your data set. It is more used like a kind of a form which you can just check out by hand. What are you going, or is your data does your data have a PID, or does it have described with some rich metadata and so on? But also we have this good tool, which Fuji, that was developed with FAIR project. And I'll just show you how it works. Okay, this is a page. I'll just put it here. Okay, and yes, Fuji, and you just have this interface where you can click to access, and you can put DOI of your your data set. I have here like this data set that is from Zenodo. You can put this DOI, and the result will be like something like this. You will have a summary of how fair is your data set. This one is pretty good fair, and you can also have with principles that all these first three principles are satisfied. This reusable is not that satisfied, but it is good. And you also you can check this out, just some details about what needs to be improved and so on. So that is about this tool. And yes, fair data is just an upgrade to research data management. So the best thing, if you want your data to be opened, is to have a good data management practice that you provided DMP, and you are following this DMP that you agreed on some with your partners or whoever is you are doing your research with, and fair data is just an upgrade of this managed data to look if you have do you have like PIDs, do you have is it put in some resource or in some source that is like data repository that is indexable and reachable by other services, and does it have a license and so on. And after all these two conditions are applied, you can go and publish your data openly. That's it. This is just some resources for further reading. I suggest you to read it, because here you have some good examples on some good practices and toolkits that you can use for every stage of your research data management process.